In this video lecture, we will understand what are offloading considerations. Now imagine a fire breaks out and your IoT system sends data to a far away cloud server, but the response comes after 5 seconds. So it's too late, right? So the question is, where should the IoT data be processed? Whether it is nearby, that is edge, or whether it is far away, that is cloud. So this decision depends on something called as offloading considerations. Now, before deciding where to process IoT data, that is whether it should be edge, fog, cloud, we must check 5 important factors, that is the bandwidth, latency, criticality, resources, and the data volume. These factors will decide the speed, cost, and the performance of the IoT systems. So here bandwidth is how much the data can be sent over the network. So if the bandwidth is less, it means that less data transfer. That is, if low bandwidth, it means less data transfer. Second is the latency. So here, how much delay is acceptable? That is, if there is low latency, then it is very important for the real-time applications. Then comes the criticality. How important is the data and the decision? So here the critical data needs faster processing and high reliability. The next factor is the resources. That is, what are the available resources, whether it is CPU, memory, storage at each location. So more resources enable better processing. Next comes the data volume. That is how much data is generated, and if high data volume is there, then it may need cloud or powerful servers. So here we have to check these 5 factors. We have to choose the right place, that is whether it is edge, fog, or cloud, and get the best IoT solution. Now we will see we'll see these factors one by one. So the factors are what? Offloading parameters which need to be considered while deciding upon the offloading type to choose our bandwidth, latency, criticality, resources, and the data volume. First is the bandwidth. So bandwidth means the network capacity. That is how much data can travel at one time. It means the bandwidth is the amount of data that can be sent over a network at one time. And if higher bandwidth is there, it means that the data transfer is faster, while the lower bandwidth causes the delays and the conges. One real-time example is the smart TV and the smart CCTV. So here the cameras will send the HD video continuously. That is, if the bandwidth is low, there will be video lagging and delay in the monitoring. That is, when bandwidth is low, the network gets overloaded with the data, and this will cause the video buffering, and there will be lag and delays in the real-time monitoring. So the solution for this is, instead of sending all video to the cloud, the data is processed near the camera, that is edge or the fog, and this will reduce the network load and provides faster response and the smoother video. One more example is the self-driving cars, where these will send high resolution images every second, and here there is low bandwidth. That means that there is a slow cloud communication. So here the autonomous vehicles capture the high resolution images and sensor data every second, and this large data cannot always be sent quickly to the cloud due to the bandwidth limits. So cars use the edge computing, where the low bandwidth slows down the communication with distant cloud servers. Therefore, the cars will process the data locally using the edge computing for instant decisions. So here, if the bandwidth is like a highway width, okay, here bandwidth is like a highway width. High bandwidth means wide highway, and more lanes means more cars and the faster movements. So bandwidth, if bandwidth is more, then the data transfer will be faster. So bandwidth is like the width of the highway, and more lanes allows more vehicles to move faster, while fewer lanes cause traffic jams. Then comes the latency, that is the delay. So latency, it is the total time taken to send the data, process it, and receive a response. So higher latency means lower response, while lower latency gives the faster results. Now one real-time example is the fire detection, where if a fire alert takes even 3 seconds, the fire can spread quickly and cause the damage. So the system must respond instantly to prevent the danger. Then edge processing will send the instant alert, that is in milliseconds, where the data is processed near the sensor, and this will reduce the delay, and it will provide alerts in milliseconds for quick action. Okay. So example here is the heart monitoring, where a wearable uh, detects the abnormal heartbeat and it needs immediate response. That is, a wearable device detects abnormal heartbeat in the patient, and this situation is critical and it needs immediate response. And sending the data to the cloud takes time due to the network delay. Therefore, the edge computing is used to give the fast real-time medical alerts here. You have to use the edge computing. Now, here low latency is like waiting time in a queue. Okay, so latency, you are waiting at a counter in a queue here. Longer queue means what? Longer queue means longer wait and slower service, and shorter queue means you will be having faster response. Okay, so low latency, faster response, and better performance and safer systems. Next comes the criticality, that is the importance of the task. It means how urgent the task is and how important a task is in an IoT system, and higher criticality needs faster response while lower criticality can tolerate the delay. Now here, high critical applications are gas leak detection, then emergency braking, where you need the immediate action, and here gas leak detection, it is very urgent. ICU monitoring, here it is life critical. Okay, so here even a small delay, it can cause the serious damage or risk to human life. Now these applications require instant decision making and real-time response, so the data is processed at the edge in order to avoid the network delay. So here low critical applications are what? Soil moisture monitoring, where delay is okay. That is, here it is not so sensitive, that is, it is not time sensitive, and they can tolerate the delays of minutes, hours, or even days. Now since the here since immediate response is not required here, okay, so the data can be sent to the cloud. Now cloud provides better storage and analysis without the urgency constraints. So here you can think it of like a fire alarms versus the attendance register here. Now which needs a faster action in between these two? So the fire alarm needs the quick action here, okay, immediate action in order to save the lives, whereas the attendance records can be updated later without any problem. So here the urgency is for fire alarm. Next comes the resources, that is the processing power, where the resources may be CPU, memory, AI power, storage. So here it refers to the computing capability like CPU, memory, storage, and AI GPU power. So more complex tasks need stronger resources, while the simple tasks need minimal resources. Now, for example, you have face recognition. Here in face recognition, AI video analysis needs high power. That is, it requires a GPU. High power GPU. It cannot run on small sensors. Face recognition involves artificial intelligence and the video processing, which requires high computational power, and small sensors cannot handle this. Therefore, the processing is done in fog or the cloud servers, and it needs the it needs the fog or the cloud here, because the fog and the cloud, these will provide the powerful processors and advanced algorithms, and they can quickly analyze large and complex data like images and the videos. So here one simple example is the temperature sensor, which will generate the small data. That is, here small processing is needed. If a temperature sensor only collects and processes small amounts of data, and it does not require heavy computation, and it can work efficiently at the edge. And here the edge devices can easily handle the simple task with low power consumption, and this will reduce the unnecessary use of high-end resources and saves energy. So here you can think it of like you don't use a supercomputer for basic maths here. Okay. Now, using a supercomputer for basic maths is unnecessary and wasteful. Similarly, simple tasks should be done using the small devices and not the powerful devices. So more resources means more power, and this can handle more complex tasks like AI, big data, video analysis. And less resources means less power, and it is suitable for simple tasks like sensors and the small data. Then comes the data volume, that is the amount of the data. So here, how much data is generated, that is important. That is the data volume. It refers to how much data is generated by the IoT devices over the time. And higher data volume needs stronger systems in order to store and process it efficiently. One example for that is a smart city where huge data volume is generated. Here you will be using thousands of cameras, millions of sensors, and the smart cities, as you all know, it uses thousands of cameras and millions of sensors continuously, and this will generate huge amount of data that cannot be handled locally. Okay, so what it requires here, it requires the cloud and the fog, combination of cloud and the fog, where it can handle large scale data storage and the fast processing, and they help manage to manage, analyze, and extract the useful information from the massive data. One example is the smart home, where small data volume is generated because it has very few sensors like temperature or motion detectors, and the amount of data generated is small and easy to handle. Then here the edge is enough. Why? Because it can process small data locally without needing the powerful servers, and this reduces the cost, delay, and the network usage. One simple analogy here is the one student versus the entire university. So one student is submitting an assignment. It will he will generate very less amount of data. It is little amount of data, whereas entire university generates massive data and it needs bigger systems. Okay, so more data volume means it will need more storage along with more bandwidth and more processing power, whereas small data means you require edge computing here, where medium data, for medium data you need fog, and for huge data you require cloud computing. Next, here we will see a quick summary of offloading considerations, that is the key factors to decide where IoT data should be processed. So the first one is the parameters which we are considering are the bandwidth, latency, meaning, example, and the best location. These are the factors. So bandwidth means network capacity, and here this will be used in CCTV. The best location is edge or fog. Whereas latency, it refers to the delay, and here example is the fire detection. Best location is edge. Next comes the criticality. It means urgency, that is it refers to urgency, and example is ICU monitoring. Best location is edge. Then comes the resources. It means the processing power, and example is the AI analytics. The best location where it can be used is cloud or fog. Then comes the data volume, that refers to the amount of data. Example is a smart city. Best location is the cloud. So here, urgent plus real time, for such type of applications you need edge, that is this type of location. Then for medium processing you require fog, and for huge data plus heavy analytics you require cloud. So this is about the offloading considerations or factors which decide where IoT data should be processed. Thank you.